Have you ever stopped to ponder the concept of zero? How can nothing be something? This seemingly simple figure, an oval void, holds a paradoxical presence in our world. It's both a number and a non-entity, a value and a void. Yet, without it, our mathematical universe as we know it would cease to exist. Consider this: the Babylonians around 4,000 years ago used a base 60 numerical system, forming all their numbers from the number 60. But they had a problem. There was no way to distinguish 68 from 608, or even 6008. So they introduced a placeholder, two wedges, where we would now put zeros. Fast forward to the 11th century, an Indian mathematician, Brahmagupta, breathed life into zero, giving it a numeric identity. So let's delve into the fascinating journey of zero, from its ancient roots to its key role in modern mathematics. Our journey begins around 4,000 years ago in ancient Babylon, a civilization known for their exquisite hanging gardens and impressive architectural feats. The Babylonians also made significant strides in the realm of mathematics. In a time when the concept of zero was non-existent, the Babylonians developed a base 60 numerical system. This system was inspired by the celestial cycle, with the number 60 representing the minutes in an hour and the degrees in a circle. But the Babylonians' numerical system had a glaring flaw. There was no way to distinguish between numbers like 68, 608, or 6008. The absence of a placeholder made their mathematical system ambiguous and challenging to navigate. To address this issue, the Babylonians introduced a novel solution. They began to use a pair of wedges, similar to our modern-day comma, to signify a void, or an empty place. This was the birth of a placeholder, a concept that was to evolve into what we now understand as zero. Although these wedges didn't carry any value of their own, they played a critical role in differentiating between numbers and eliminating confusion. This Babylonian innovation was a significant leap in the development of mathematics. It laid the groundwork for more complex calculations and the expansion of numerical systems. But it was just the beginning. The concept of a placeholder was merely a hint of the more profound idea that was to come, the notion of zero as a number in its own right. The story of zero doesn't end in Babylon. This ancient civilization may have set the stage, but it was on the other side of the world, in the vibrant land of India, where the concept of zero was truly born and found its identity. Thus, the Babylonians paved the way for the evolution of zero, but it was in India where zero was truly born. The tale of zero is a mesmerizing journey, a testament to human ingenuity and the pursuit of knowledge that continues to shape our understanding of the world. Fast forward a few centuries, and we land in India, where the first written evidence of zero was discovered. As we delve deeper into the Enigma of Zero, we find ourselves in the vibrant landscape of Indian mathematics, around the 7th century. Here, the concept of zero as a number, not just a placeholder, began to flourish. At the forefront of this mathematical revolution was the esteemed mathematician Brahmagupta. Known for his profound wisdom and curiosity, Brahmagupta was a trailblazer who dared to tread where others hadn't. His understanding of mathematics was far ahead of his time, and his contributions continue to resonate in classrooms around the world today. Brahmagupta began to define zero as we understand it now. He wrote, "When zero is added to a number or subtracted from a number, the number remains unchanged, and a number multiplied by zero becomes zero." This might seem obvious to us today, but back in those days it was a radical concept. Brahmagupta called zero sunya, which translates to void or empty. His idea of sunya was a breakthrough, a leap forward in the world of mathematics. It was a concept that went beyond the physical representation of nothingness. It was a number with its own identity, its own rules, and its own purpose. And yet, despite Brahmagupta's monumental work, the symbol we now associate with zero, that familiar oval shape, was not his doing. The hollow and oval figure we now recognize as zero was yet to make its debut on the mathematical stage. Zero's journey was far from over. It had found its identity in India thanks to Brahmagupta, but the symbol we use today was yet to be introduced. That would be the work of another mathematician, in another time and place. Brahmagupta gave zero its identity, and yet the symbol we recognize today would be introduced centuries later by another mathematician. This is where we pause for now, as we prepare to meet the man who would bring zero into the light of the Western world. Enter Fibonacci, the 13th century mathematician who introduced the Western world to our familiar hollow and oval figure of zero. Let's dive into the world of the Middle Ages, where the Italian mathematician Leonardo of Pisa, better known as Fibonacci, was about to make a significant mark in the history of numbers. Fibonacci was, in many ways, a bridge between cultures. He had been introduced to the Arabic numeral system, including the concept of zero, during his travels to North Africa. Fascinated by this efficient system, Fibonacci set about introducing it to the Western world. He wrote a book titled Liber Abaci, or Book of Calculation, published in the year 1202. This book was revolutionary as it explained the benefits of the Arabic numeral system, which was far superior to the Roman numerals that were predominantly used in Europe at the time. In the Arabic numeral system, the value of a digit depends on its position, and the zero plays a crucial role in distinguishing between numbers like 68, 608, and 6008. In contrast, Roman numerals lacked a symbol for zero, making calculations cumbersome and complex. Fibonacci's book was not an overnight sensation, but it gradually gained recognition. The mathematical community began to realize the advantages of the Arabic numeral system, and slowly but surely it gained traction. With Fibonacci's Liber Abaci, the symbol of zero, that hollow and oval figure, started to become a familiar sight in the Western world. It's important to note that Fibonacci did not invent the concept of zero. He merely introduced it to a part of the world that was unfamiliar with it. Yet, his contribution was monumental. He was the catalyst that allowed zero to become universally recognized, setting the stage for the development of modern mathematics. With Fibonacci's contribution, zero was now universally recognized. But why is it so crucial to mathematics? Zero is not just a symbol. It's a powerful tool that underpins our modern decimal system. This humble figure, a simple circle, holds an immense power that shapes the way we understand and interact with the world around us. Think about it. Without zero, how would we distinguish between 1, 10, or 100? It's the quiet hero that creates space between numbers, giving them room to grow and multiply. It's the silent sentinel that guards the place value, ensuring that each digit holds its rightful position. Zero is the canvas upon which all other numbers paint their stories. It's the stage that allows numbers to perform their mathematical dances: addition, subtraction, multiplication, and division. Zero is the magic that turns a 1 into a 10, 100, 1,000, and so on. Without it, these transformations would be impossible. But zero isn't just about holding places and enabling growth. It's also about absence, about the concept of nothingness. This might seem like a simple idea, but it's actually quite profound. The ability to conceptualize the absence of something, to understand that something can become nothing, is a fundamental aspect of human cognition. Zero also plays a vital role in the realm of the infinite. It's the doorway to negative numbers, the mirror that reflects the positive number line into the realm of the negatives. And in the world of fractions, zero sits at the nexus point, the fulcrum around which all fractions pivot. The power of zero extends beyond mathematics. It's woven into the fabric of our technology, our science, our economy. It's encoded into the binary language of our computers, driving the digital revolution. It's integral to our financial systems, enabling us to calculate complex transactions, interests, and prices. And so we see that zero is far more than a simple placeholder or a symbol for nothing. It's a key that unlocks the complexity and beauty of our numerical system, a catalyst that drives our progress and understanding. Without zero, our understanding of the world, as well as our technological advancements, would be radically different. The history of zero is indeed a testament to human ingenuity. This seemingly simple digit, a hollow oval, took a grand journey from the ancient Babylonian civilization, where it served as a mere placeholder in a base 60 system, to India, where it found its identity as Sunya. It was here that the number zero was born, thanks to the luminous mind of the mathematician Brahmagupta. Through his writings, zero was given a voice and a role in mathematical computations. And let's not forget the contribution of Fibonacci, who introduced this invaluable concept to the Western world in the 13th century. The essence of zero, from its origin to its role in our modern decimal system, is a testament to the creativity and problem-solving prowess of humankind. Without zero, our mathematical landscape would be vastly different and certainly less efficient. Next time you see a zero, remember its fascinating journey from nothing to something and how it continues to shape our world.